So in this little tutorial, I'd like to go over strategies that you can use to extract 3D surface information from a Civil 3D drawing. I'll comment that in most cases when exchanging surface information between MicroSurvey products, that is MicroSurvey CAD and FieldGenius, and MicroStation or Civil3D or Bentley or a few other products, usually a land XML file is exported from the other software, and that can easily be imported into MicroSurvey CAD. But in some cases, because of communication, that step never happens, and in this case the Civil3D drawing has wound up in my hands. So what I'd like to do is take advantage of the fact that there is a tin displayed in this drawing that gives me surface information, but it's just in a format MicroSurvey can't work with. So here's what we'll do. So first of all, what I'll do is I'll pick on that tin and I'm going to do right click and I'm going to ask to have a look at its properties. So what you'll see is this shows up as an AECC DB surface tin, and so that's a typical name that you'll see for Civil3D specific entities that only Civil3D can work with fully. MicroSurvey CAD can just display them. So the first thing that I want to do is make it into a more primitive CAD entity by exploding it. So I'll type on explode here, and I'll pick that tin and enter. And so now what I'll find is, again, I'll pick on it and I'll take a look at its properties, and you notice how now it's a block reference. And so because this block reference is kind of embedded in a complicated layer structure, which you'll see if you go in here, you'll see lots of things are dependent upon each other. I'll just simplify things by exporting just that tin into a separate drawing. And that's a really smart thing to do with FieldGenius anyway, because in many cases you don't need to look at all this stuff, and sometimes it can cause performance problems with your smaller data collector. So I will export by using the command W block down here in the command line. That allows me to export some entities. I'll tell it that I just want to export that tin. I'll hit enter here, and I'll give it a name for the file that I want to create. I'll call this one just the tin. And as long as you don't change the insert units, then there won't be any rescaling in between the export and the import. So I'll say OK here. And now it's created a new file, and I can go back to Project Manager, and there's my new just the tin drawing. I'll open that up, and you'll see it consists only of the tin, and if I look at its properties, it's still a block reference. Next thing I want to do is explode that block reference, because I'd like to turn this into just primitive 3D faces and lines that are going to be easier for MicroSurvey CAD to read. So I'll select all the entities, window that whole thing in, and that should turn it mostly into triangles. I think I found there were some places where it didn't explode completely. No, actually it looks pretty good. Okay, so now if I look at the properties, we'll see that we've got 3D polys. Well, it looks like we've got some circles, which I don't want to use. And we've got 3D faces and poly lines. So those are the main things that I want to work with. And those are the main things that the surface creation routine will grab onto. So now let's make a surface that is going to be in MicroSurvey's memory. So I'll go extract a surface. I'll go with the default ground name, pick OK, and just window in all those polylines and 3D faces. I'll see down here it's added 446,000 points or 4,600 points to the surface, which is a reasonable size for when you're staking a surface in FieldGenius. If you have much larger amounts, then you'll start to have performance issues. So I'm happy with that sizing. Next thing that I want to do is verify that the surface looks right, because I want to view the tin. So I'm just going to type tin, select the ground surface, and I just want to show it. And we'll see what we're looking for is a kind of a rainbow range of coloring, so that that proves that we don't have unusual highs and lows. And of course I want to make sure that it does correspond to the 3D face that we already have there. So I can repeat that command from a different perspective as well. So that looks like we've got an accurate surface. And If I look in surface operations, we'll see that there's the surface that we've created. And if I want to have a look at the detailed info about it, we can look up its high, its low, we can look up the number of triangles. And remember before I was saying probably a good idea to keep things under, let's say, 5,000 points. And there's other options for simplifying surfaces if you need to send them to the field. Okay, but I am happy that I built the surface. The last step now is save it as a format that both MicroSurvey CAD and FieldGenius can read, so that they're working directly with the surface information and they're not getting mixed up with the other CAD options. So I'll pick on surface operations again, highlight my ground surface, and here I'm going to write a QSB. And I can put that into, I'll put it into whatever folder I happen to be working in right now. And I'll call it just the surface. And it's a QSB format file, which MicroSurvey CAD can read if you do here, and FieldGenius will also be able to import if you go into the Surfaces menu. Okay, now we've turned that Civil3D surface information into MicroSurvey surface information, and you can go to work with it. Thanks for watching along.